video is for mixed practice number 1 over the first 2 investigations and lesson of polynomials, unit 9. A couple questions here, then we'll do a couple practice problems from practice number 2. Number 1, we're going to put this polynomial into standard form. To put standard form, your exponents need to be in decreasing order. So I start here with negative x squared, and then the next term will be plus 2x. The highest exponent of this polynomial is 2, that's the degree, and we call a polynomial degree 2 quadratic. If I have degree 2, that means there has to be 2 roots, right? The roots is equal to the degree. That's not necessarily x-intercepts. It could be imaginary, but there are 2 roots. The number of turning points, the maximum number, is 1 less than the degree. So if my degree is 2, 1 less than that is 1. And the end behavior here, I'm going to talk really quick about how you can do it without a graph, but then you can look at the picture. My leading coefficient is negative of degree 2, which means that my arrows are both going to be pointing down, right? Even degree has arrows in the same direction. Negative means they're both pointing down, which means that both arrows will be going towards negative infinity. If that's hard for you to do without a picture, then make a picture. Right? Graph negative x squared plus 2x. You can see that both arrows are pointing down on this graph, so my end behavior was correct. Number 2, I give you the picture. Number of x-intercepts. There's 1, 2, 3, 4, 5. The number of turns here, 1, 2, 3, 4 turns. Now if I have 4 turns, remember the degree is always 1 more than the number of turns. So the potential degree is 5, which is what we call quintic. The end behavior, if the arrows go in opposite directions, you're going to connect the end points of the arrows. And you should see there that that line is going down, so you have a negative trend, so the leading coefficient is negative. For end behavior, as x goes to negative infinity, that means on the left, the arrow is going up to infinity. As x goes to positive infinity, on the right, the arrow is going down towards negative infinity. All right, we're going to look at number 4, and then that'll be it. Okay, so I have to figure out multiplicity and then sketch a graph. To find the degree, I add the multiplicities, or the exponents. So I have 3, 1, 1. That would be degree 5. It's called quintic. And quintic polynomials with degree 5 have 5 roots, real or imaginary, 5 total roots. It's equal to the degree. If I have degree 5, the maximum number of turning points is 1 less, which is 4. And let's talk about end behavior here. When I sketch my graph in a minute, because my degree is odd, the arrows are going to go in opposite directions. The leading coefficient is positive, which means that my graph is going to have a positive trend, which means it's going to start low and end high. So that means on the left, my arrow is going to be going to negative infinity. On the right, my arrow is going to be going up. And we will look at the picture after we sketch it to make sure we sketched it correctly. The first root, x cubed, is the factor. That means you have a root at 0. Its multiplicity is 3. That's the exponent. 3 is odd, so you're going to cross the axis. And polynomials of degree 3 are called cubic, so that's what my root's going to look like. The next root is the opposite of 4, which is negative 4. Its multiplicity is 1. That's also odd, so you're going to cross the axis and look linear, so it's going to cut straight through. Finally, the last root is at positive 6. Its multiplicity is 1. And just like the last root, it's going to cross and look linear. Now, when I sketch my graph, I'm first going to plot the points 0, 6, and negative 4. Now, I know where my arrows have to go. At negative 4, I'm crossing through that root and looking linear. So I'm just going to come straight up through. At 0, I said I'm going to cross through, but I'm going to flatten out and look cubic. So when I get there, I'm going to flatten out, and then at 6, I come straight back up and through. If you're not sure if you did the picture right or your behavior correctly, let's go ahead and look at a picture. This graph is x cubed times x plus 4 times x minus 6. All right. Now, if I zoom out, you should see that you do cut through at -4, you flatten out at 0, and you go back through at 6. All right, if you have questions on the other problems on this practice, go ahead and ask your teacher for some help.